Welcome back to Big Picture Statistics and Computer Analysis. We've been on a bit of a hiatus, but we are back. Today we want to talk about the binomial probability formula. Basically, it's a straightforward formula. The probability of x successes is given, the probability of x successes in n trials is basically given by this formula. So x is the number of successes, n is the number of trials, p is the probability of success in each trial, and q is the probability of failure in each trial. So q, in essence, is 1 minus p. It's a complement. If there are x successes out of n trials, the number of failures must be n minus x. So let's look at a sample problem with this, and then we'll look at the same problem using SPSS. So basically, here's a good problem. So let's take a look at this example. A survey found that 17% of US adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether Google News is a major source for news for them. Find the probability that exactly 2 of them responded yes, at least 2 of them responded yes, fewer than 2 of them responded yes. So for the first part, exactly 2 responded yes. We use that formula with x equals 2. We have a sample of 4 adults, so n is 4. Probability of success is 0.17 because they stated in the beginning 17% of US adults say that Google News is a major source of news for them. And you proceed with the computation, you get the probability. So this is the probability that exactly 2 of them responded yes. Now, if we want at least 2 of them responding yes, well, at least 2 means 2 or more. And since our sample has 4 people, at most there could be 4 people. So this basically boils down to the probability of 2 plus the probability of 3 plus the probability of 4 of them. So we compute all of these separately, and then we sum them up at the end. So we're going to get this probability here. And the last part, fewer than 2 of them respond yes. So fewer than 2 means strictly less than 2, which means either 1 or 0. So we can do it this way. Probability of 0 of them saying yes, that they get their news from Google News, and the probability of 1 of them saying yes. So we do the computation, and we sum up these 2 probabilities and we get our answer. Okay, now let's look at the same problem in SPSS. Alright, so here's the SPSS. We have a new data file here. Alright, so what we need for this problem in SPSS, we have to input some data in order to use SPSS. The 2 pieces of data that we're going to input is the number of trials, which is n. So we had 4 trials, and the probability of success, which is p. So the probability of success was 0.17. We will enter that. And what I'm going to do, I'm going to go to the variable view and I'm going to label these variables. Now, what I'll do first, I'll put both of them on scale level of measure. So I have them on scale level. And what I will do here, let me rename these. So this one we're just going to call n for the number of trials. This one we'll call p for the probability of success. Number of decimal digits, this one maybe, let's get 4 decimal digits. Alright, so let's proceed to do it. So the first part of the question, if you recall, it wanted to know the probability of exactly two of them responding yes. So here's what we do. We go to transform, compute variable. There we go. And the binomial probability distribution is a discrete probability distribution. So we will go to this PDF and on central PDF. So we will pick binomial probability, PDF binom now. The binomial probability, it used to be called Bernoulli trials not long ago. This PDF, Bernoulli, and binom are the same thing, but we'll go with this since it's called this. Alright, so what we have here, it tells you what you need to input. You input the quantity is the value of x you're looking for. L is the number of trials, PROB rather, is the probability of success, what I called P. And you need to set a target variable here. So let's see, for the first computation, let's call it probability of A. Alright, so here's what I'll do. I will enter this value. So basically the first part said they wanted to know the probability that two of them responded yes, that Google News is a good source of information. And what I need to input here is L. So let me highlight L, put it in. And the last question mark, I need to put the probability of success, which I called P in my data file. And this will do it. If I click OK, what it did, it entered the probability here. But what I want to do, I want to request more decimal digits. Let me request 4. So we'll go back to the data view. There we have it. Alright, now the answer when we did it manually was 0.119. We got 0.1195, which is close. This really has to do with round-off error. But basically SPSS gave it to us. Alright, so the next part, go back to transform. The second part, they wanted to know the probability of at least two of them responding yes. So at least two of them responding yes. What we need to do here, let's make a new target variable. Let's call it B. Let us delete this. And let's do the same thing. We go to PDF, non-central PDF, PDF binom. And basically what we need here, if we want at least 2, that means 2 or more. So what we need to do, we need to do the probability of 2 of them plus the probability of 3 saying yes in that survey, plus the probability of 4 of them saying yes. So it will look like this. Now what I have to do, I just have to replace these other question marks with what's indicated here. So the first question mark gets replaced by L. The second question mark gets replaced by P. And the same goes for this one. First question mark, I'll put the value of L. The last question mark, I'll put the value of P. So we'll proceed this way. There we go. Alright, so we'll click OK, and it should display it in my data file. There we go. And again, if I want more decimal digits, I can just go here and I can request more decimal digits. So there we go. Now, this one is actually exact. This probability, when we did it without SPSS, rounded to 3 decimal digits was 0.137. If you round this to 3 decimal digits, it will match. Okay. Alright, let's finally do the last part. The last part, we'll do compute variable again. Let's call this probability of part C. Alright, so in that part, they wanted to know the probability that fewer than 2 responded yes. So if fewer than 2 responded yes, we're just going to delete all of this. Let me delete it for you. So let me... Alright, same thing, go to this, PDF, non-central, PDF binom. So what we need to do, we need to get the probability of 0 of them saying yes, plus the probability of 1 of them saying yes. So delete that, put 1, and then replace the appropriate question marks with n and the probability p. So let me do that for you. So there we go. That one is gone. Enter this one. And let me get rid of this one. Okay, we'll go to the computation. And again, we want more decimal digits. Let me put 4. Back to data view. So if you round this to 3 decimal digits without the SPSS, we had 0.863. So it is exactly on the money. So this is it. This is basically how you do binomial computation, binomial probability computation in SPSS.